Online Standards are pleased to announce the release of this new product, which has been designed to complement the online training course Smoke Control Made Simple, which goes through the steps involved in determining the requirements of a smoke, heat and exhaust ventilation system, or a SHEVS system. Now, the SHEVS Online Calculator is a web-based application which will change the way the requirements of smoke control systems are determined. This product has been produced to alleviate the current shortfall in the fire industry for a method of determining these requirements and for enforcers to be able to check schemes. Enforcers at the present time can't check schemes because they haven't got the necessary skills. This course and this calculator will give them those skills. Now, smoke control has been viewed by many people in the fire safety industry for many years as something of a mystery, and many are put off by the imagined mathematical complexity of the subject, whilst many others seldom come across premises which require smoke control provisions, and so they don't feel it necessary to invest their time in learning about the subject. And what this means is that there's very few practitioners in the field of smoke control relative to the number of premises that have such provisions installed in them. Now, fire and rescue services nationally have been reasonably proactive in training a few of their fire safety officers, and between them they have a significant body of expertise in the subject. Now, it is surprisingly common that new proposals from fire engineering companies often show a lack of understanding of smoke control, and they often place heavy reliance on computational fluid dynamics analysis, which is often based on assumptions that are neither realistic nor rigorous. Now, these comments are not made speculatively, but they are founded on years of observations of proposed and installed smoke control facilities in buildings where it has been observed that the most accurate interpretation of the expected fire and smoke behaviour has lain with the trained fire and rescue service personnel and not with the designers. Whereas sprinkler installations have clear and unambiguous guidance in published documents, such as the LPC rules for automatic sprinkler installations, there is no single clear and unambiguous guidance documentation for smoke control. Now, the guidance can come from a range of documents, not all of which necessarily agree with each other all the time. Now, almost invariably, smoke control in buildings is used to compensate either directly or indirectly for a lack of passive compartmentation. Now, compartmentation in a building controls the spread of fire and smoke by putting physical barriers around the fire. Now, control of the spread of fire is dealt with by essential complementary measures which perform in one of two ways. Either the fire spread is controlled by a sprinkler installation, or by controlling the size and location of the fuel beds. Now, this equivalence between smoke control and compartmentation is true whether the objective of the smoke control is for protection of life, protection of business continuity, or some other objective. Now, smoke control provisions can fail to meet their design objectives either because knowledge of the importance of them is not retained by the building user, or because they have not been designed and installed correctly in the first place. Now, experience has shown that over the years, compartmentation has a tendency to remain in place as people can see it and understand its role as protecting people from means of escape, for example, or property within the building. Now, experience has also shown that smoke control provisions performing an equivalent role to compartmentation are often compromised during the lifetime of the building due to a lack of understanding of the role or the requirements of that smoke control. What is the objective of that smoke control? They forget the main objective here. Now, for example, cases have been witnessed recently where smoke vents have been sealed shut because they've started to let the rain in, and no one thought there was a problem by sealing them off. No one actually thought, what functions are they intended to perform? And another situation where smoke curtains designed to drop on the local detection of smoke have been sealed in their houses, in their house position, because of false alarms and problems with rehousing them. Recent cases of poor designs that have been witnessed include situations where natural ventilators have been hinged at the top so that do not present anywhere near the required aerodynamic free area ventilation. In other words, they haven't got the right AV factor, they've not got the right area ventilation. There's also been situations where the spill plumes that have been anticipated by the design fire engineers bear no resemblance to the actual spill plumes that would occur in the event of a fire. They've got too much of a lower fire size. They might have thought, well, I'll go for a 2 megawatt fire, and we've actually found out to be a 5 megawatt fire, so the system won't work. So what you're going to find is there are many buildings throughout the globe where smoke control provisions have been compromised and may not function as intended. And we also have new buildings or alterations to existing buildings that are being constructed based on inappropriate assumptions, or again with heavy reliance on CFD, computational fluid dynamic modelling, and little correlation to the actual conditions that would exist in the real world. It is the building users, their employees and the visitors to the buildings who suffer. It is they who will foot the bill and suffer the reduced levels of protection. Now, without realising it, the building occupiers are in a situation where they are heavily dependent on the statistical improbability of a fire instead of being able to depend on the fire safety provisions that have been installed in that building. In other words, they're relying more, I hope they're into fire, because that system might not work. And this is not how fire safety is meant to work. It's meant to include preventative measures, of course, however, to reduce the likelihood of the fire occurring, but it's also meant to complement this with means of escape and property protection facilities that will ensure that safety is maintained even if a fire does occur. You can't rely on the fact that, well, what's the chance of having a fire? Now, if smoke control were better understood by both designers and auditors, then the current situation could be expected to improve. Now, with more and more buildings being constructed that incorporate some form of smoke control, it is essential that the current mystique surrounding smoke control be dispelled. Now, it's not a difficult topic to come to terms with, and those that do almost invariably discover a field that they will find both fascinating and rewarding. Legislation and procedural guidance have been put in place to ensure that building designs are not the sole responsibility of the design team, but they are fully checked for compliance with the functional requirements of the building regulations. Today's dynamic environment requires both designers and the checkers to be fully conversant with smoke control principles and practices. Now, with this in mind, we have developed the 11-step guide. Now, this is a revolutionary new method which, if followed, will go through all the stages required to check a chef's system. Now, this method is valid around the globe and should lead to advancements in the understanding of this potentially complex subject. Now, we have released this 11-step guide as an online course which attracts 40 hours CPD, where you can get further details from here, www.frconline.co.uk. However, to complement this online course, we have produced this online calculator, which goes through all the steps and allows you to quickly and accurately carry out the calculation.